So we are now recording. This is lesson 1.7 about functions. And I forgot I should have done this before we started, but I have to calibrate because anytime I change my display settings, my calibration is off. Okay? So in this lesson, you're going to learn to determine whether a relation is a function and find function values. And as I said, I'm going to talk quickly because if you were actually watching the video at home, you could hit pause if you didn't get it. It's really good for any of your teachers if you miss class and you don't have the notes, you can watch the video. So, okay, for vocabulary, and I'm just going to put these up here. Oh, I'm in the wrong thing. There we go. It's basically a relationship between an input and an output where there is exactly one output for each input. The only thing I will add here, because it will be helpful in a minute, my x values cannot repeat. I don't know if you can see that in the background there, but basically I'm going to refer to this a lot. In a function, the x values cannot repeat. A discrete function is basically a graph that only contains points. And a continuous function is basically when you connect those points. Again, the definition says a smooth curve here. I don't like this because even though this is true in Algebra 1, it's not true in Algebra 2. You get things like absolute value equations, and then they don't have a smooth curve, and the headphones are out of your ear. Okay. The vertical line test. This is something we're going to use a lot. So we're going to use it. It'll make more sense as I do the examples. That if a graph represents a function, when you draw a vertical line, it can only pass through the graph once if it's a function. And I'll explain that in a minute because that's really important. Function notation and nonlinear function. Nonlinear function is basically a graph that is not a straight line. So let me talk a little bit about the grid. I want it visible. I want to close that. I want to make an XY coordinate plane, or basically something that'll look really close to it. And this way I can talk a little bit about functions and vertical line test. Okay, so for our purposes in algebra, pretty much everything we deal with is going to be a function. For our purposes, most of the time, we're going to use the terms interchangeably, okay? But the reality is there are some equations when you graph them that are not functions. When we're dealing with straight lines, unless we have x equal to something, and we'll get into that later in the year, we're going to have functions. So if I were to draw this red curve here, this is actually represents a function. And the reason it's a function is anywhere I draw a vertical line, a line up and down through this function, I'm only going to hit the function once. Correct? So when I say hit the function, touch somewhere on the red line. Okay? So for instance, this point is not on the function. This point is. But when I draw this line, the only place I'm going to hit this function is here. This orange line is not a function because if I draw a vertical line, I'm going to hit this function in more than one place. Correct? So we have a lot of really funky words here, and this is ultimately all we're talking about. Okay? I'm not going to worry right now in this video too much about function notation, because as I said, the idea of the video is 10 minutes, you get the highlights. So we want to determine whether each relation is a function. You will remember that I told you to write down x doesn't repeat. And the reason that that's the case, let's go back to this. Okay. If I were to put these as ordered pairs, 1, 2, 3, 4. So that's ordered pair 4, 0, correct? And this is ordered pair 4, 1, 2, 3, 4, 5, 6. And this is 7, 8, 9. You see here how the x values are repeating? And we'll do with this more throughout the year, but mathematically that doesn't happen. When we have a function rule, which we'll talk about probably more in chapter 2, if I take a number and I do something to it, I don't sometimes get one answer and sometimes get another. 2 plus 3 is always going to be 5. If I take 2 and I add 3, I'm not sometimes going to get 7. Okay, so that's the basis of why this works. So, x doesn't repeat. Look at this first example here. Domain is my x values, correct? Okay? Do I have a repeating x value? Well, my x value, that's 1, 4, and 1, -4. It's hard to see that. I'll write over it in white. Mathematically, that can't happen. So my x values are repeating. Sometimes one goes with 4 and sometimes one goes with -4. We mathematically can't do that, so it's not a function. Is it a real function? No. Why? Because the x is repeating. The fancy word is x cannot pair with 2 different y's. Kind of like dating. Not really a good idea if you go out with 2 people at the same time. There might be some controversy. Now, I do find this kind of amusing. That's x's rule. X can't go out with 2 people at the same time. Y is allowed to. If your y repeats, you're still considered a function. Okay? So right now, I don't really that concerned about you understanding why that's the case. Get it? Why? I just want you to know this. So, -2, let's just think about what this mapping tells me. It tells me that -2 pairs with -3, correct? It tells me that 0 pairs with 6. It tells me that 3 pairs with 6. Okay? I can have a y value that repeats. Okay? I cannot have an x value that repeats. Is that a function? Yes. Because it's okay for the y value to repeat. For the next one, is it a function? Can somebody tell me if it's a function? Raise your hand and I'll point to you, but I won't use your name. I don't have a volunteer?
No.
Oh, it's not on there. Okay, so that says 2, 1, 3, -2, 3, 1, and 2, -2. And you know the people at home are like watching this video being like, why couldn't they see that? But I realize that this orange background with the black writing sitting in the audience here, it's difficult to see. So do I have x values that repeat? I have 2, 1, and 2, -2. Can I have that, though, to be a function? No. So is it a function?
No.
Why not?
Because you can't have 2. You can't have 2 2s.
You can't have 2 2s going with different, you can't have 2 x's going with different y values. Or sorry, the same x going with different y values.
And there's 2 3s.
What?
And there's 2 3s.
Oh, and there's 2 3s. I didn't even notice that. Great job. There's 3 -2. So we can't have that.
So with the 3 -2 and the 2 -2, you can have the same because the y values.
Awesome. So if they didn't hear you at home, and you could actually play this for your parents and be like, listen, that's me. If we just had the -2s repeated,
Right.
because they're the y values, it would be a function.
Okay.
But the fact that the x values repeat
It would be on
can't be a function. Okay? So, now we have some drawings. There's no numbers. Is this curvy thing a function?
No.
If I draw...
It passes through x twice.
Okay,
But
no, it actually, okay, that's just the x-axis. okay? You can't have x's repeat, because if this helps you a little bit visually, if I just put a point here, this actually point, maybe that's an x value of 2, y value of 0. And maybe this, oh sorry, this one would be negative 2. Right? Actually, even though they're both going through the x-axis, the x value isn't the same. That would be if they both went through this point here. The y value is actually what's the same. So that's why we also talk about the vertical line test. Because if you think about what's called the vertical line test, if it's graphed, it's real easy to say like vertical line, and place vertical lines. Okay? So you could draw a line there. You only go through one point on the graph, on the blue curve. One line there. You only go through one point. This. Oh, he failed. What test did he fail? Vertical line test, he failed. Okay? This one. This is a closed dot, which means that this includes 0, correct? This is an open dot, which means it does not include 0. Okay? If you remember, if I asked you to graph, okay, and I like sometimes when you guys look at me and like I can tell like you just have a question. If I asked you to graph x is less than 5, if you remember on a number line, you were supposed to put an open circle on 5 and it's everything to the left. If I put x is less than or equal to 5, then you filled it in. So open dot means that value is not included. So in this case, does this graph pass the vertical line test? Yes, it does. Okay? And if you're in my class, normally you'll get a whole explanation. Technically, this is a quadratic. This is a piecewise. This is like Math 3 honor, so don't worry about it. Okay? Now, the other thing we want to do, I'm going to skip this word problem because as I said, I want to just hit the highlights here, is I do want to talk a little bit about function notation. So function notation, the way you would read this is f of x, the function of x. For our purposes, you can just think of that as y. Okay, you're used to, and you'll see that a lot. Y equals something. But when we use function notation, we use this term f of x. When this says f of 2, it's saying basically take this equation and instead of x, plug in 2. So what is negative 4 times 2? What is negative 8 plus 7? And that's the answer. Okay, so let's talk about the next one. What it's saying is we're going to plug negative 1 in for x. We're going to solve the whole thing. And then we're going to add 5 at the end. So negative 4 times negative 1 plus 7. We're going to do this whole thing, and then we're going to add 5. Does anybody know why I just threw some brackets on there? Awesome! So that I do the inside first. Because that reminds me, I do everything first, I add the 5 at the end. That way I don't like mess up my order of operations. Negative 4 times negative 1 is?
4.
4
Plus 7.
Plus 7 is?
11.
And then 11 plus 5 is?
16.
Okay? Now we're going to get really fun. This one says, we're going to take the function of 1. We're going to solve it. Then we're going to find the function of negative 2. We're going to solve it. And we're going to add those two together. Okay? So I'm first going to take negative 4. I like writing a different color for what I'm substituting because I feel like it helps you follow kind of what I'm doing. So negative 4 times 1 is?
Negative 4.
Negative 4. And negative 4 plus 7 is?
3.
Positive 3. Correct. Now I have to do this equation. So that's negative 4 times negative 2, correct?
Yeah.
Plus 7. What's negative 4 times negative 2?
Positive 8.
Positive 8 plus 7 is?
15.
So that's positive 8 plus 7.
And then
What's
add it because of the addition sign between them.
right? So add it because there's a plus in between, and what do I get?
18.
18. Okay, so hopefully today in algebra support, that's a little bit of review for you if you've seen lesson 1.7. If you haven't seen lesson 1.7, then it's a preview of things to come, right? Which still helps you. And if you get confused, you can watch the video at home. And better yet, if you know how to do it all and your friend says, how do you know how to do it all? And you don't want to help them, tell them to watch the video.